Morning, we're going to go over magnetos and setting points in the four-cylinder Mercury magneto, as well as setting the points in the dual point six-cylinder point box, battery-driven ignition. We'll start with the magneto. Magneto, couple of things to know about magnetos. This green type distributor cap it was conductive, and it was replaced by a tan one, which was non-conductive material. They do not carbon track, and then the later ones were white, blue, gray, and a number of different colors. But the original ones were tan. They are not conductive. This one is conductive. They used to coat them with gyptal inside. Gyptal worked, but it still carbon tracks underneath it. It's red. Called gyptal. Okay.
So it doesn't have anything to do with the composition of the cap itself?
Yes, it does.
It does, okay.
Yes. Apparently this material right here is non-conductive, and this plastic here is conductive.
And that would be the older Bakelite?
Correct. It can get carbon tracking on top of it. Apparently this stuff doesn't. I've never seen one carbon track, and I've never had one fail that I am aware of. And when I started in the business in 1965, we've done a lot of distributed caps since '65. Okay, next thing on the four cylinders, there was a earlier Fairbanks Morse magneto, which never had a non-conductive cap, but they did coat it with gyptal. Here's one that's not coated, here's one that is, and they had two different types. Actually three different types. They had ones that pushed in from the side, held in by a screw, and they had ones that were screwed in like this right here. And the very early ones, like the KE9 or KF9, they were actually pushed in like an automotive one, and they did tend to fall out. That's why they went to the screw type.
Absolutely. Being that they're upside down.
Yes, exactly. And enclosed.
Gravity overcomes all.
In enclosed space, they did blow up occasionally. So these things had a couple of different rotors. Like this, the Mercury one had a red rotor like this, which you could only use with certain caps. And then they came out with the one that was colored like this. And again, they had some blue ones, white ones later on. And the earlier Fairbanks Morse magneto had one that had a half moon cut in it, and another one that was splined. So there were two different rotors in those as well. Okay, last but not least, Fairbanks Morse used this type of points right here. You can see it's got a little notch in it. It's got two screws at either end. And the later ones, which had a permanent post like this, only had one screw to work on. The Mercury ones. This is an earlier type Mercury magneto, and the later one had these other points, which are a little bit easier to set. The later ones are far preferred. Aftermarket and later on, Mercury came out with point sets, specifically in this size, which is used in the six-cylinder as well. This same exact one here. Came out with plastic ones which tend to break. These older phenolic wrapped fiber, you can kind of see it by looking at the top. You can see that the lines kind of go around. They stand up extremely well, and they don't crack. And these points were basically meant to run for 500 hours. So they are fileable and they are cleanable to a point. Unlike the OMC ones, which they really recommended you replace anytime you open up, Mercury was not against filing the points. If I'm going to file these points, I tend to take them apart. You can unscrew them with a very small wrench if you have an ignition wrench set, which I do, but I'm not going to use it. It's a little bit easy to see. You can unscrew this piece right here, and or just flop it out to the side and use a point file like this on it, on this surface as well. But I don't have much luck with the point file itself. I use 320 grit, and I take a piece of 320, tear it, and then I take the points, I put it on a point file, which is a very convenient piece, and I file it like this, using this sandpaper or 320 grit.
Now, the actual surfaces of the contacts,
Yes.
they appear to be flat. And what I've
Yes.
gotten from you in the past is it's almost better if you put just a slight curvature on them.
Correct.
And they're easier to align that way.
And they're done. It tends to get in the center.
Right.
Excellent. Yeah, good comment. But if you're doing it this way, I like them out of the unit because you don't want to get any of this crap inside of the points or inside of any of the wear blocks or surfaces, or you'll destroy your cams. But this is how you do the points if they need to be cleaned up. Good point, yes. Okay, so I think the first thing we're going to do here is set up to dwell the points, to align the points so their opening coincides with the change in magnetic flux from north to south or south to north, depending on what you're talking about. In this particular distributor, it operates in both modes. In a two-cylinder version, usually it goes from south to north, and that's when the points break. But on this one, it has a dual set of magnets that the flux changes 4 times in one rotation of 360 degrees.
With these points, I noticed that you have a very, very large hole. Being from the automotive end of it, this used to be quite stationary.
Yes, it is stationary.
So you couldn't actually move those points a lot more.
You cannot with this one right here.
You can't.
That goes down over a fixed post, which is stepped,
Okay.
and this part is a smaller hole. That bigger hole goes into a step. I don't have one of those right here, but they are fixed, both of them. That's why this is easier to set. You only have that slide right there. This set right here, you've got a large hole there and a large hole there.
Right.
So you can actually wiggle these points around, but it still has a fixed.
And what I noticed with that setup is that you have a little more adjustability because of the distance between the lobes.
Yes, you do.
And you can set it either further back or rotate it forward.
Okay.
I don't know what the significance of that is. And
Well, I'm not fond of these because they're a bitch to set. Compared to those, they're difficult to get synchronized.
yeah, and that's where, of course, with that Mark 55 that I have questions as to whether or not I'm even going to be close as far as having it.
Well, you'll find out. If my explanation is good enough, it should be easy for you to set them.
Well,
We'll
back you up if we can.
What we normally use, I normally use is the Mercury. And for years, I had this milliamp meter right here for years. I never knew what it was for until somebody gave me this early service manual. I would say it was from the late 50s. And lo and behold, there was my little continuity meter. And that's what I use for doing these points because it has a very, very wide swing of the needle. The Mercury, the needle movement is not anywhere near as great.
So like DVOM versus that style of diagnostic.
DVOM doesn't have. I'm not an electronics guy, but all I know is that this measures a much larger or much tinier deviation in the conductivity. Okay,
Yeah,
I'm not sure what it's called. Is the name for
and
it?
they do require a small amount of voltage
To run across that. Yes,
Right.
they do. Yeah, right.
And that's good to know if you're testing diodes or anything like that, because you don't want to use that.
No, you don't want to use. You don't want to test diodes with anything that's that's got a needle that moves because it requires electricity to move it. Okay, so the first thing I want to do is I want to test my condenser, make sure it's good, and make sure it has the right value. Very important for spark propagation, especially in the 4-cylinder. And I also want to make sure my coil is good. So I use the Mercutronic to test both of those items and make sure they qualify. I use the Mercutronic book. It gives you a very quick run through of how to test those items. Just go through the series. It gives you how you test them and so forth and so on. It gives you a coil test and rotor test and a whole number of other things because it's very well spelled out. So I do test those items, make sure that they qualify, and like I say, the condenser is very, very important to spark propagation.
You want to take that off?
No, I'm gonna leave it in there. I've got it disconnected. So the next thing I want to do is I want to disconnect all my wires going to this. And make sure there's nothing that's gonna interfere with some of my measurements that I take. Okay.
As you can see, it's user-friendly.
Yeah, well, reasonably, yes it is. Okay, so I have for this a 4-cylinder breaker point dwell plate. That's the part number down there in the bottom. It includes the plate and the pointer arm, which I'll pull out in just a second. So this notch right here is to accommodate the air vent. I don't put the screws in the bottom because I find that the tension from this is plenty enough to make it work fine and be stiff, so I don't worry about it. And the next thing I do is I go for this one that I've modified to do the shaft in. So here we go. If you look, this thing has in here a little peg, and that fits into this missing tooth. So when we go on it, we're in a very specific place. We tighten the screw.
That missing tooth also aids in clocking that distributor, so you just can't put it in any old way that you want.
Correct. It matches up to the missing tooth in the distributor, into the distributor tower, which is in here. And if your cogged wheel on top is aligned with the flywheel, you should be in good position to have things work well. I highly recommend using the manual. Remembering this stuff is impossible. I've been doing it for a lot of years, and the manual gets open. All right, I'm gonna put this in the vise. Okay, and if you see, we have here points closed, points open. So I'm gonna plug this machine in, and I'm going to attach one somewhere here where it won't slip off, which it always does anyhow, no matter how hard you try. And I got one on here. And let's hope that we're fairly good. Okay, so if you notice, I've written on here closed. That's when the points are closed, and when they're open, you'll see this meter, this thing jump quite a distance. All right, so we get a real wide opening there. So here we are, we're aligning the plate up to get our points, if you see over here, are open, and our points are going to close right now. So I'm going to align this little black mark with the end of the pointer right here. Okay, so if we wiggle it, we can see the needles moving. So we're right on the points open, point closed. Now, if you're anything like me, sometimes I do this backwards because it is possible to do that. I've done it and then wonder why it doesn't work, why the points don't seem to operate the way they're supposed to. You want to make sure you read the sign that says points close at this point. And I've got closed written right there, so it is now closed. The points are dwelling together, allowing electricity to flow through the coil, and they are going to open they're a little bit off. So we want to set these up for Mark 58 and later, so we want them to open right in here. So I want those points to open a little bit sooner. So what I'm going to do is I'm going to move this pointer, hold it right about here, and I'm going to attempt somewhere near the half. We want it over in this, a little bit off of the mark, because it's going to, if I change them, this is going to move as well. So
What's the
we're
screw
gonna-
for here?
it's the wrong screw. Okay, thank you. So I want to have these points open. Don't keep it on the mark. Move it right about right there,
Okay.
just on that side of it. Okay. And let's see. And I want the points to break, so I'm going to you have to really keep loosening them up just a little bit at a time. You don't want them too loose, then they wander. Okay, let's just see if that's good. This can be a very slow process and take a long, long time, and I'm not going to spend a lot here, but sometimes it goes very quickly, and some days when you don't hold your mouth right, it takes forever. Okay, so let's just see where we are back here again. Okay, so we're a little bit, I'm gonna move this a little bit this way. They're closed. Open, closed, okay. Now let's just see. Good, we're within the black bar on both of them, so we've set the points correctly. These ones you have to be very careful setting them up because those little cast pot metal pegs break off really easy, so you don't want to get heavy duty prying on them. All right, let's go that. Okay, points are closed, and we're within the black mark. And points open, and we're within the black mark for Mark 58 and later. Now, I did forget about one small thing here. There's one thing that we want to do as well, and that's set this, the spring tension of this properly, especially if you've got a racing engine. If you look, this spring thing has a little square box right there, and that is the spring tension that we want to have on this set of points so they don't float. If they're down here, they'll float, and if they're up here, you're going to have very rapid wear on that cam. So we want to have them sitting in that little box was the ideal position. And you want to make sure that you're not touching anything that's going to short this thing out. So we're looking at points closed, and we are really getting there. Or if I got it shorted out somewhere. Let's try moving it down into here. Am I touching anything? I don't think so.
No?
Okay. I'm up against the peg. I'm way, way too heavy. So how do I fix that? Well, I take and bend it in carefully, because if you go too far, you've got to take everything apart and start all over again. Unscrew this and bend this spring way out here.
So you bent this spring in?
I bent it in by pushing in like this.
Okay.
Can you get it over on this side like that? All right? I'm pushing pretty hard because it's a long way off. When it gets close, you want to be very, very careful. Okay, so let's try it again. See how we
So
are.
what this kind of represents to me is the fact that you don't want to take and set this all up and not know what spring tension you have.
Yes, we want to do this first.
Yeah.
I went a little bit too quickly here.
Well, that spring being too tight, you'll probably wear the rubbing block off
Correct.
the points.
And then the points gap will change.
Right.
So we won't have it won't be in tune for very long.
It will definitely change in a hurry. You will notice the difference instantly.
Jeez, this one's really
That
tight.
is tight. Wow.
Yeah. I haven't seen one this bad this way before. Plenty the other way.
Usually too loose.
Usually way too loose, yeah. That's a real pain in the neck when that happens.
I give that a good one.
Okay, you did? Okay. Here, we give it one more shot. Let's see. Yeah, you did. Give it another one. He's a young man. He's got strength in his fingers, which I don't have.
Is that a Mercury approved squeeze you're giving there, Matt?
Let's pretend. Okay. Squeeze it one more time there, Matt. Okay, that's good. All right, let's see how that one looks. And we're right within the box.
That's because Matt checked the manual to see how to squeeze it.
You're right. You
Direction.
did. Good direction. Okay, so I'd say these points are set up and ready to go. You install a Magneto in the engine, make sure all your belts are lined up and your pulleys are lined up correctly, and now you've got your points braking at the right time. You have not done your timing yet. The timing is done with the Magneto on the engine and a certain degree of rotation, and there's usually a stop screw that you adjust to get your timing where it's supposed to be. But that timing tells the spark plug when to fire. This right here is the dwell, and for a battery-driven ignition and for the Magneto ignition, it's the timing between the magnetic flux and the points, and you want to have them synchronized to get the maximum spark out of the unit. So that's what we're doing here. We are not talking about timing the engine itself. We're timing the magnetic flux with the opening and closing of the points. There are some other things that can be done. This right here is a tool for aligning the points. If the points are way the heck off, you get this tool in there. It's a bit of a hassle, but you can stick it in. It's got two different ends for different thicknesses of this plate right here. And you can bend it fore and aft like this to align the points so that they come together and they're not pried apart. Or you can twist it to get them so that they're not together at one side and open at the other. You can align the faces. These faces are aligned
Concentric.
concentric.
Is that a tool you usually use that? Is that a tool that you usually use?
I normally don't have to.
Yeah.
Normally the points are pretty good, but you can. That's what that tool is for.
And the spring tensioner, do you usually have to use that?
I always use that before I set the points up.
Can I get one of those right down at Harbor Freight?
No, I don't think so. I think you have to look around. It's a part number 91-2929406.
Palmer's got one of those.
And they made a different
think he
one
knows what it's
too
for.
that had a long arm and a spring inside of it, which was kind of like it hooked like this and you pulled it off in this direction. I had part of one, but I've never had a complete one.
So you can't use your fishing scale.
Right, correct. Okay, that's it for that point box.